Welcome all. This is a very good problem from pre-score test based on the interference pattern. So the question says a plano-convex lens made of material with refractive index 1.5 is placed on a flat glass plate. The radius of curvature of curved surface is 8. The lens is illuminated with wavelength 600 nm and concentric bright and dark rings are observed in the reflected waves. The interference pattern has a dark spot at the center which is surrounded by 50 dark rings, the largest of which lies at the very edge of the lens, that means here. So let us see how to analyze this problem. Suppose this is our arrangement and let us say the ray comes like this. Let us call this ray as 1. This ray will undergo partially reflection over this surface and a part of the ray will be reflected back. Let us call this ray 2. Other part will undergo transmission, go down, reflect at this surface and return back. The reflected ray from the lower surface returns as ray 3. So interference will be caused because of interference between 2 and 3. So if this thickness is T, then what you can say about the path difference between 2 and 3? Delta x, let us say delta x is the path difference between 2 and 3. So you see over here what is happening. This ray 3 is undergoing extra path length of how much? 2t, isn't it? T going down, T coming up. Plus it is going a reflection at a denser medium. That means an additional phase difference of pi is introduced. That means an additional path difference of lambda by 2 is introduced. So we can write the path difference between 2 and 3 will be what? 2t plus lambda by 2. And we know it should be n lambda for bright fringe as it is a constructive interference, and it is n plus half lambda for dark fringe destructive interference, where n is what? N is any integer 0, 1, 2, which defines the order of the bright or dark fringe. Now let us focus on the dark fringe. So for the dark you can say what? If you equate lambda by 2 cancels and you get 2t is n lambda for dark fringes. Now from here you can very easily see that if n is 0 over here, n equal to 0, that means it is a dark fringe, and for n equal to 0, t is what? T is equal to 0. That means this edge gives you dark fringe. So if we draw the central line, let us say this is the central line and the edge line center. If you observe the pattern, then the center will be, this is the 0th dark, this is the first dark, this is the second dark, and similarly it goes like this, like this, like this, and the farthest dark comes over here, isn't it? But we know that there are only 50 dark fringes. That means corresponding to t equal to 0, it is 50th dark ring. That means for 50th dark ring, t is equal to what? T is equal to 0. So for 49th, just here, if you see, for 49th, I mean, if you take t will be this value. You see, as you go inside, t goes on increasing, and that is why the pattern is observed. Okay, so for 49th, I mean, this will be, this is 50th, and this is 49th, and the next one, this will be 48th, and so on it will be. So for 49th fringe, what will be t? N will be 1, so t will be lambda by 2. Similarly, for 48th, what it will be? N equal to, now n equal to 2. That means t is equal to lambda. So this is actually an arithmetic progression, and for 0th fringe or the central dark spot, t will be what? You can extrapolate and see that it will be 25 lambda, and this is nothing but the thickness at the center, h. So if you put h equal to 25 lambda, then lambda you know 600 nm, then h comes what? 15 mu m. 15 mu m. So this is answer A, first part. Okay, this you got. So A is correct. A is correct. Now you have got the h. Now let us draw radius from the center of the curvature of the upper length, and this will be what? Let us, this radius we are knowing that it is r, and we know this one is what? Let us call the radius of the 50th dark fringe be small r, then, and here this will be what? R minus h, r minus h. Now you see over here what you can say for this from the Pythagoras theorem, very easily you can say it what? R is equal to r square minus r minus h square. If you solve it, you get what? H times 2r minus h. Now h is very small as compared to radius, so we can neglect and we will write it what? This as 2r h. Now r you know, h you know. If you put, then you get r is equal to what? You get r is equal to 1.54 centimeter. Okay, so this is the radius of the 50th dark fringe. So you got option D. A and D are correct. Now let us see about the focal length. Focal length formula we know what? 1 upon f is what? Mu, which is the refractive index of the material, minus 1 upon r1 minus 1 upon r2. r1 and r2 are the radius of curvature. So r1 is what? This is infinity, and this is what? 8. So if you put, then you get mu is equal to 1.5. So if you put, you get what? 0.5 upon 8, which is 1 upon 16. That means f is what? F is 16 meters, but the option given is 16 centimeter. So that option is wrong. So the correct options are A and D. This is the answer. So I hope you got the concept, and if you have any doubts, any queries, any questions, please feel free to ask in the comments. Thank you.